In this video, I'll show you how to solve the ALEKS problem called elemental analysis. This problem is going to give you percent composition for a molecule that has one or two or maybe three different elements in it, and your job is to figure out the empirical formula. The first thing that we're going to do is use a periodic table to get the atomic masses of all of the atoms that are listed in this particular compound. We have zinc, and the atomic mass of zinc is 65.38. and that is grams per mole. And then we also have oxygen, which is 15.999 grams per mole for oxygen. And that's all the information that we need from the periodic table, so we'll get it out of the way. Now, our job when we're coming up with the empirical formula here, we are going to come up with the number of atoms of zinc and the number of atoms of oxygen in this particular compound. We're starting with a percent, which is a unit, kind of like a unit of mass. So this 75.3%, we can think about that as 75.3 grams of zinc, and the 24.5%, we can think about that as 24.5 grams of oxygen. We don't have to take this path, but this is kind of like a shortcut, easy way to do it. So what we have here are the grams of zinc. We can't plug grams of zinc into an a molecular formula. This needs to be moles or atoms. So what we're going to do is take these grams of zinc, the 75.3 grams of zinc, and we are going to convert that gram unit into moles of zinc. And we'll do this conversion using the atomic mass that we got from the periodic table. There are 65.38 grams of zinc in every mole. We're going to do this for every single atom that we have the data for. So I have got 2 atoms. That means I'm going to do this calculation 2 times, once for the zinc, once for the oxygen. If you have 3 atoms, you're going to need to do the calculation 3 times, once for each one of the atoms. And the way that we have this set up, grams are going to cancel for each one of these different atoms, and we're going to be left with units of moles. I'm going to go ahead and do my math for the zinc. 75.3 divided by 65.38 gives me 1.152 moles of zinc. And I'm going to do the same thing for the oxygen, 15.999. Wait a minute, what have I done here? This should be 24.5 grams of oxygen. I'm not sure how I made that mistake. Sorry for that confusion. We're taking the masses that we have from the percent data. That's what we should be starting with. So 24.5 grams of oxygen divided by 15.999 is 1.531 moles of oxygen. Okay, so we have figured out the moles of zinc and the moles of oxygen. So in a way, our formula kind of looks like this: zinc 1.152, oxygen 1.531. That's not conventional notation. Usually the subscripts in our molecular formulas are integers like 1 or 2 or 3. You might be tempted to just say, oh, let's round this. Let's just call this 1. That's a little risky. This number is a little too far away from 1 for us to feel comfortable doing that kind of rounding. It should be basically exactly 1. So in a situation like this, and you'll probably end up in this situation where these numbers are not coming out to be integers, what you're going to do is analyze the number of moles that you have for each element. Maybe you're going to have 3. You're going to look at all 2 or 3 of these numbers. You're going to find the one that is the smallest, and you're going to divide everything by that number. In doing this, we're not changing the ratio of the moles of zinc to the moles of oxygen. We're just changing the value of these numbers. So this is going to cause our moles of zinc to now be 1, and our oxygen is going to be 1.329 moles of oxygen. So we've improved this formula a little bit. We now have zinc 1 mole and oxygen 1.329. So one of these is an integer, but the other is not. So that means we have to keep working on this. Now, most of the time when you get to this part of the problem, most of the time both of these numbers are going to be integers. And if that's the case, you're done. The problem is done. But if you're in a situation like I'm in right now, where we did the division and they're still not both integers, the next thing that we have to do is multiply. We're going to multiply trying to turn these numbers right here into integers. And when we do the multiplication, we're going to start by multiplying everything by 2. There's no point in multiplying by 1. It doesn't do any good. And we're going to see what that gets us. 1 mole of zinc times 2, that's going to give us 2 moles of zinc. And 1.329 times 2, that's going to give us 2.659 moles of oxygen. We're going to have a look at these numbers. These numbers are still not integers. Like the zinc is remaining an integer, and it will. So now we're at zinc 2, oxygen 2.659. Still not an integer, and still too far away from an integer to feel comfortable rounding. If you are in this situation, for a lot of times you do this multiplication, these numbers are both going to end up being integers, and if that's the case, you're done. But if you're like me and that didn't work, what you're going to do is back up. You're going to undo all of that, and instead of multiplying by 2, we're going to multiply by 3 and see what that gets us. And if this doesn't work, we're going to back up and try multiplying by 4. So 1 times 3 is 3, that's 3 moles of zinc, and 1.329 times 3 is 3.987 moles of oxygen. Now that is close enough to 4 that I feel comfortable rounding that. That's what I'm talking about in terms of getting nice and close. So now we have 3 moles of zinc and we have 4 moles of oxygen. ZN304 is our answer.